Okay, students, we're now page 471 in your book, Mod 3, Topic 1, Lesson 3. Remember, since this has got 6 lessons in it, we will have a quiz either after this lesson or after lesson 4 over the first 3 lessons. Okay, these are the key terms that we're going to go over and hit today. So our first thing is our warm-up. Go ahead and pause the video, work these problems out, and then hit play, and you'll see me work them out. I will also show you shortcuts as we go through this here. All right. So one of the things you want to do is first off, ask yourself, does 4 go directly into 22? No, it doesn't. Next thing I want to ask myself is, can I reduce one side or the other? Yes. This reduced down to 5 halves. Now I can ask that same original question again. Does 2 go into 22? Yes, it does. 11 times 11. That means I must multiply the top one by 11. So 5 times 11 is 55. And there'd be your answer. Notice that's simple math. The long way, which will always work, is, as you've been taught throughout middle school, is just to go ahead and cross multiply and set them equal to each other. That's your butterfly. So you get 4x equals 220, and then divide by 4. And for most of you, you need to put that in a calculator, but that also gives you 55. Notice my shortcut way doesn't require a calculator at all. Now, number 2, there is no reducing of 5 23rds, and 5 does not go into 23 evenly, so I do have to do the straight, just cross multiplying. So I get 25 equals 23n, and last step, divide by 23. And there's my answer. 3 should be easy. When I see 16 over 16, that's 1. So that's the exact same thing as 8 over 8 for 1. 4, again, I would ask, does 4 go into 10 evenly? I mean, directly right away? No. But if I reduce this down to 11 halves, now 2 does go into 10 5 times. So again, I can multiply by 5 here, and that answer is 55. But like I said, you could always just do the cross multiplying if that's too difficult for you. All right. Okay. Angle bisector theorem and proportional side theorem. Most books just call it the angle bisector theorem. Okay, we're just gonna get to an example. I'm not gonna start proving it. It takes too long. You're not gonna be doing that on a test or the DCAS. Okay, so we are now on page, let's see, 478. Okay. So we're not going to do the proof of it. I'm just going to show you what it is. And like I told you, it's usually just called the angle bisector theorem, not the angle bisector / proportionality theorem. So when I have an angle bisector, notice it says AD bisects angle BAC. So that means that arc compared to that arc. There's an angle bisector. When that happens, what that's going to do is it's going to divide these sides proportionally. So let's say I have a 10 there and a 5 there. And let's say I have a 20 here. What would this length have to be? Well, if I go ahead and look, split that right here, I can say, if I want to start it down here, I say 5 times what is 10? So I'm going to double it. That means I got to start down here to go up there, and I double it. And so 20 times 2 is 40. Okay, or I could have started here and said 10. How do I go from 10 to 5? In multiplying or dividing, I divide by 2. Then I would have what number, x divided by 2 equaled 20. Well, then that's 40 again. Okay, most people like to multiply. Now, as far as setting up the proportion, again, it doesn't matter which way you set up. So I can go 10 over 5 If I go 10 over 5, I have to do the same corresponding sides on the other side. That would be x, because that's what we're solving for, over 20. And then, of course, I can say 5 times 4 is 20, and therefore 10 times 4 is 40. Okay, shortcut. Obviously, you could cross multiply and get 5x equals 200, and then x equals 40. Okay, let's go ahead, and we're not going to look at the proof. All right, so here's the actual name. Like I said, most people just call the angle bisector. They're calling it angle bisector slash proportional side theorem. A bisector of an angle in a triangle divides the opposite side into two segments whose lengths are in the same ratio. Remember, ratio is a fraction as the lengths of the sides adjacent to that angle. So it means the same ratio in both triangles as we had done. Okay, so now here's applying it. Okay, let's get to one right here. Let's go ahead and erase all this, start from scratch. So this is one that guarantees on the DCAS. You'll have one of these like this in your test as well. I see this and it tells me that CD bisects it. So boom, I immediately put my arc showing that it bisects it. I could go ahead and say 20, how do I get from 24 to 8? I'm dividing by 3. So that means I got to go this way also and divide by 3. And 30 divided by 3 is 10. And I'd be done. That's real quick if you're going to do it in your head. If I'm setting up for proportion, I could say 24 over 8. I got to do the same corresponding sides. 30 over the x. Remember, that was the x that we had to figure out right there. And again, 24 didn't go to 30, but I could reduce this down. 24 over 8 is 3 over 1. And then 3 times what is 30? 10. So 1 times 10 is 10. And there's your answer. Shortcut. Okay. You could sit there and do 24x equals 240, cross multiplying those. So, okay, so here's another one. It says it bisects it. Okay, so again, I could go this way and say 11 times 2 is 22. So 9 times 2 is 18. If I'm not needing to show any work. If I need to show work, I would say, for example, 9 over x equals 11 over 22. And of course, I want to reduce this down to 1 over 2. And then I can cross multiply and I get x equals 18. Okay. Here, AD bisects angle A again. Okay, now look what it says. AC plus AB equals 36. Now, I only can have one variable. So if I call AC x, then what does AB equal? I need to solve that for AB. That means I have to subtract that x across. So AB equals 36 minus x. So now I got to put 36 minus x right here. This is one that students usually miss, and you usually would see something like this on the DCAS. Okay. So now I set up my proportion again. So I have x over 7, for example, equals the corresponding sides, 36 minus x over 14. Okay. So now, since I have x in both these, you could just cross multiply. You get 14x equals 7 times 36 minus x. Now, many of you are going to be tempted to want to just distribute. You can distribute and have more steps and bigger numbers to work out. But what's simpler is to divide each side by 7. And the reason I'm doing that is because 14 divides by 7 evenly. If it didn't, I would distribute. So now I get 2x equals 36 minus x. Obviously need to add the x across. And I get 3x equals 36 divided by 3. And you get 13. Sorry, 36 divided by 3 is 12. So x equals 12. Okay, now I go back and read the question. It doesn't say, let's see, back up here. It's up here. Solve for AC and AB. So it didn't say solve for x. So that means I got to take my x and plug it back in. So AC was x, so AC is 12. And now I plug 12 in there. 36 minus 12 is 24. So AB is 24. That's a common error students make on the DCAS and even on regular tests, is they forget to go back and read the directions to see if you're done. Do they want you just solving for x, or they want you to solve for the length? So you have to plug the x back in or whatever variable they're using. Okay. So here, they want you to solve for, notice they're asking you to solve for AC. They aren't asking you just to solve for DC. So what I'm going to do is I'm going to go ahead and solve for DC first, and then add AD plus DC together to get my AC. Okay, so I'd have 14 over 6 equals 16 over x. I can reduce that fraction down to 7/3 equals 16 over x. Cross multiply. I get 48 equals 7x divided by 7. Okay, and that gives me 6 and 6/7. So that's 6 and 6/7, but remember that's not what they're looking for. They're looking for the whole thing. So now I add 6 plus 6 and 6/7 together, and I get 12 and 6/7 equals AC. So again, make sure you read the directions, even when you think you're done, to make sure you're answering the right question. All right, theorems of triangle proportionality. Okay. So if I have a triangle, okay, and it says those are parallel. Excuse me. Well, remember, we have a trapezoid midsegment theorem that says if those are midpoints, E and D are midpoints, it not only is parallel to the base, but it's also half of it. Well, this is sort of similar, but it's not midpoints, so it's just proportional. That's why they call it triangle proportionality. So that means whatever that length is divided by the whole length equals that length divided by this whole length. So those two ratios have to be the same. Okay, which is what they're saying over here. Again, it doesn't matter. I did the AE over AC and AD over AB. They just do the reciprocal. It doesn't matter. Okay, you get the same answer. All right, so let's go on to some examples here. We're about to prove. We want to get to, so here's where you can write it down for your notes on your theorems page. If a line parallel to one side of a triangle intersects the other two sides, then it divides the two sides proportionally. Okay, and then so here's an example. So let's go ahead and erase all this, start from scratch. Okay, so again, since these are parallel right here from the parallel symbol, we know that they split the sides proportionally. So I could say, for example, 9 over 12 equals the same corresponding piece, x over 16. Okay, and I can reduce this down to 3/4. Then I can say 4 times 4 is 16, so 3 times 4 is 12. So x is 12, which is what you get right here. Notice they're just doing the straight cross multiplying right away. They aren't reducing the fraction. Okay, I always reduce fractions. I can use my brain, keep it smaller. Okay, now here, if this length is 4 and the whole length is 18, that makes this 14 right there. Okay, so now again, I can do my proportionality here. I can do 14 over 4 equals x over 6. I can reduce this down, divide by 2, 7/2. 2 times 3 is 6. 7 times 3 is 21. So 21 over 6 reduces, it's the same ratio as 18 over 4. You can check that. Okay, now just so you know, I don't always have to go vertically. Let's test it. I can go horizontally. I could say 4 over 6. I went from here to here. I have to start on the left here equals 18 over x. And again, I can reduce this down to 2/3 equals 18 over x. 2 times 4 over x, 18, and 4 over 6, 18 over x. Did I do that right? It's 9. That's going to be 7/2, and that is, oh, 21 is not right. What did I do? Oh, 7/2 and 7/2, yes. Oh, I see what I did. This is why I have an error. I got to write the right 4 over x equals 14, not 18. 18 is the whole length. 14 over x. There we go. So now reduce it down. 2/3 equals 14 over x. 2 times 7 and 3 times 7, and you get x equals 21 again. Okay, so I can go horizontally or vertically as long as I go corresponding pieces. Okay. Here, a little more work. Okay, they gave me the whole length of 20, and they gave me this as x. They don't give me what this is a number, so I can actually figure that out. So there's multiple ways of doing this. What I would suggest to do is, since they gave me that 20 as a whole length, I want to use the whole length over here as well, which is then 16. And then since the x here, that corresponds with the 12 there. So if I go x over 12, those are corresponding, and then I have 20 over 16. Okay, whole to whole, piece, same corresponding piece, same corresponding piece. I can now reduce that fraction. Divide each common GCF is 4. I get 5/4. And then I have 4 times 3 is 12. 5 times 3 is 15. Okay. Now the converse of that is also true. So if the ratio of this divided by this equals this divided by this, or reciprocal of this divided by this equals this divided by this, then it means that those two segments are parallel. Okay, remember the then part is what we're trying to prove. So then we're proving that the two lines segments are parallel. So if they break into proportional segments, then the line segments are parallel. That's just the converse. Okay, let's go ahead and work some of these out. Determine whether M, now don't forget, you could always pause the video right now and do it yourself and then hit play and see if you get it right. Or you could watch me do the first one and then you pause it and do the second one and then play it. Okay, this is how you got to be smart and how you use the videos. Whether it's my video or any video online, math video online, you're trying to learn from. Okay, determine whether they're parallel or not. So I need to see if, for example, 2.7 divided by 7.2 equals 4 over 9. They have to be corresponding. Okay, now if I want to use my brain, and the quickest way to do that is to get rid of the decimals. So I'm multiplying by 10, move over there. So now I really have 27 over 72. Well, what's the GCF between 27 over 72? 9. So divide each by 9, and I get 3/8. So the question now, does 3/8 equal 4/9? If you don't know, when I cross multiply, they have to equal the same. So what's 3 times 9? 27. What's 8 times 4? 32. Are those equal? No. So the answer is no. Those proportions are not equal. Okay, so now you could pause the video and do A here. Well, I guess it should be B. I don't know why they put A and A. Oh, I see. They did similar. No, not quite. No. All right, they didn't do that. I was figuring out why. There's just got me an error there. Okay, so again, if I have 3 over 24, that would have to equal 4 over 32. 3/24 is 1/8, and 4/32 is 1/8. So the answer is yes. Same ratio, so therefore those are parallel. Okay, so that's what that says. So this one just says proportional segments theorem. So we just dealt with 2 parallel segments. It doesn't matter how many parallel segments there are. It's the same. So if 3 parallel lines intersect 2 transversals, then they divide the transversals proportionally. Okay. So let's look at one of those. I guess I don't have it there. Maybe we'll have it in the lesson questions. All right, triangle mid-segment theorem. This is just like the trapezoid mid-segment theorem. Okay. What it's saying is, if I take the midpoints of 2 sides, connect them, then it's going to be parallel to the base and half of the base. 7 is half of 14. Okay, so the mid-segment of a triangle, here's the mid-segment. So the mid-segment is that right there, is parallel to the third side. So that's why I had the parallel symbols on there. And half the measure of the third side. 7 is half of 14. Okay, that's an example. You'll have either that one, something similar to that, or the trapezoid mid-segment theorem, which is the same idea, except for you're adding the two bases and finding the average of them to get the mid-segment. Okay. That's doing the same idea, except for from plotting points. I don't want to spend all this time. That's the example. So that's the angle bisector theorem. It says name that theorem. Okay. Here's a triangle proportionality theorem. Notice it didn't tell me AB. I mean, A is the midpoint, B is the midpoint, so it can't be triangle midpoint, mid-segment theorem. Here we're trying to prove that they're parallel, so therefore these ratios must be the same ratio. Okay. That's the converse one. Let's look at, okay, so we've done those ones. Let's look at one here. Here's an example of the one with the multiple parallel lines, cutting the two transversals. Okay. So they didn't have one back then. Here it is right here. Okay, so again, I said a proportion. Remember, this whole thing is proportionality. So you're setting proportions all over the place, all throughout this chapter, big time. So I can say 4 over 6 equals 6 over x, for example. Okay, that reduces it to 2/3 equals 6 over x. 2 times 3 is 6, so 3 times 3 is 9. Okay. So the key is that these are parallel. If they're parallel, then we can do that. If they weren't parallel, we could not set up those proportions. All right, let's do D. Okay, this will be the last one we do. Yep. Okay. So same idea, except we have all algebraic expressions. We see that they're parallel, so it's going to divide it proportionally. So I have 4x minus 3 over 3x minus 1 equals 8x minus 7 over 5x minus 3. Now there's no reducing here, so we got to actually cross multiply. And when I have two terms in numerator and denominator, I put parentheses around them and cross multiply. So I have 4x minus 3 times 5x minus 3 equals 8x minus 7 times 3x minus 1. And now go ahead and multiply through. So I get 20. I'm just double distributive property. 20x squared minus 12x minus 15x plus 9. Okay, combine like terms, I get 20x squared minus 27x plus 9. Okay, now we do it here. I'm going to do this one up top. 24x squared minus 8x minus 21x and plus 7. Combine like terms, and I get 24x squared minus 29. That's an x squared minus 29x plus 7. It's a quadratic. First thing you do with all quadratics is set equal to 0. So I'm moving, this is the higher one, so I move the whole left side over. Okay, so I'm now, that's not division. So I'm subtracting 20x squared. I'm adding 27x, and I'm subtracting 9. Okay, so now I have 0. I have 4x squared minus 2x minus 2. Okay, now since they're all even, I can divide each term by 2 to simplify, get smaller numbers. I get 0 equals 2x squared minus x plus 1. Okay, now here you got to remember your factoring or quadratic formula from algebra 1. So this is, like I said, this is the type of problem you can see on the DCAS. Well, they'll have all this algebra involved with the geometry. The geometry concept's easy. This divided by this equals this divided by this. That's the geometry concept. All the rest is algebra 1 skills. And so if you're poor with your Algebra 1 skills, or you forget them, boom, now you're in trouble. You might understand the geometry part, but you can't do the problem because you don't know your Algebra 1 skills. Okay, so I'm going to show you the Carlson method of factoring. So 0 there. Okay, and I will also send out a separate video just on my method of factoring. So you learn it the quickest way. All right, so this first term times this first term has to multiply to that term right there. The only thing it multiplies to 2 is 2 and 1, and x and x. Okay, then I draw two smiley faces, there to there and there to there. Okay. Now, in any factoring, you have to figure out the two numbers that it multiplies to. It multiplies to AC, which in this case is 2 times 1, or 2, and it adds to B. You need to know this. This is, most of you learned the AC method last year. Okay, and B is, oops, I brought the X there. B is -1. So what two numbers multiply to 2 and add to -1? That would be -2. Oh, this one, let's make sure I have anything blown, because that would not factor. I can't believe they give you a quadratic that didn't factor here. I'll make sure I copied everything down right. 4x minus 3 over 3x minus 1. 8x minus 7, 5x minus 3, yes. Okay, 4x, 5x, 8x minus 7, 3x minus 1. Okay, 20x squared minus 12x minus 15x is minus 27x plus 9, yes. 24x squared minus 8x minus 21x is minus 29x plus 7. Okay, I'm adding this across, is minus 2x, and that's a minus 2, and that is a 4. Dang, so that doesn't even factor at all. Okay, so what this one would be is you'd having to plug this in the quadratic formula. So let's go ahead and go to quadratic formula now. Okay, now this could be a graphing calculator problem. If it's a graphing calculator problem, on the DCAS it is, in y sub 1, I could plug in 0, and in y sub 2, I could plug in this whole equation right here. 2x squared minus 1x minus 1. Then I hit second calc number 5. That's the intersection button. Okay, and then I would go ahead and hit enter. It'll say first guess, you hit enter, second guess, you hit enter. And then the guess itself, you move it to, if there's two answers, you just move the cursor right or left, the right or left arrow keys until you find the one you want. And then you repeat the steps, go to second calc 5, first guess, second guess, and then on the guess, move it to the other intersection point. And those are going to be decimal answers. They're irrational numbers. Okay, that means they have a radical in it. Okay, so if we do a quadratic formula, which they do give you on the DCAS, remember that is -b plus or minus the square root of b squared minus 4ac all over 2a. So remember, this is a, b, and c. So -b, 1, plus or minus the square root of b squared, which is 1, minus 4ac. Now, since this is geometry over 2a, remember a is 2, so it's over 4. Since this is geometry, you're going to always end up with a positive underneath this radical. So remember, the negative has a negative is positive, so 1 plus 8 is 9. Oh, dang it, it does factor. Oh, that's why. All right, well, we're practicing. I'll go back to the factoring next. That's why I see what I blew in the factoring part. All right, well, you're going to see quadratic formula as well. You see all the methods. Graphing calculator, I just told you right there. Now you're doing quadratic formula, and then I'll do the factoring next. All right, so remember, square root of 9 is 3, so 1 plus or minus 3 over 4. So that means 1 plus 3 over 4, or 1 minus 3 over 4. You need to know how to read that correctly. So 1 plus 3 is 4, divided by 4 is 1, or 1 minus 3 is negative 2 over 4, or negative 1/2. There's my two answers, okay, which I would have got on the graphing calculator as well. Okay, now I'll go back and show you where I blew it on my factoring here. So when I said it multiplies to AC, I told you that was 2 times 1. It's 2 times negative 1. That's where I blew it. So it's negative 1, which gives me negative 2, and adds to B, which is negative 1. And so that's negative 2 plus 1. It gives me negative 2 times 1 is negative 2, and negative 2 plus 1 is negative 1. Okay, so these are the two numbers. So again, as I told you, it's got to be 2x and x, because the first terms have to multiply to the 2x squared. I draw two smiley faces right here. The other two, so I have a 2 here. 2 times what is negative 2? Negative 1. That's why these smiley faces, these are connected. They have to multiply to one of these. And then I have 1 times what is positive 1 here? Positive 1. And then I said each of those equal to 0. Each, because it's equal to 0, it's an equation. So now I have 2x plus 1 equals 0. Subtract the 1 across and divide by 2. Okay, and there's your negative 1/2. Okay, that we had right here. There's the negative 1/2. And then for the other one, I have x minus 1 equals 0. Oops, x minus 1 equals 0, x equals 1. And there's that one right there. Okay, so you can factor it. You can use quadratic formula. If it's a graphing calculator problem, you can put in the graphing calculator. All right, that goes ahead and ends it. It was a long lesson because I did a bunch of examples, and this last one was a lot more work, and we did it 3 different ways. Okay.